For centuries, humanity has looked up at the night sky and asked one fundamental question: are we alone? Given the sheer size of the observable universe, the mathematical probability of extraterrestrial life seems almost certain.
To put this in perspective, there are billions of galaxies, each containing hundreds of billions of stars. If only a small fraction of these stars have planets, the number of potential worlds is staggering. Starting with the famous Drake equation, scientists attempt to estimate the number of active, communicative civilizations in our galaxy. This formula considers factors like the rate of star formation and the percentage of planets that could support life. Furthermore, even if we use conservative estimates for each variable, the equation often suggests that thousands of civilizations should exist within the Milky Way alone. This leads us to the heart of the mystery. Transitioning to real-world data, the Kepler Space Telescope revolutionized our understanding of exoplanets. Since its launch, we have discovered thousands of worlds orbiting distant stars, many of which are similar in size to Earth. Most importantly, a significant portion of these planets reside in the Goldilocks zone. This is the specific distance from a star where temperatures allow liquid water to exist on the surface. In addition to looking far away, scientists are also hunting for microbial life right here in our solar system. Mars remains the primary candidate, with evidence of ancient riverbeds and organic molecules in its soil. But Mars isn't the only target. Icy moons like Europa and Enceladus may hide vast subsurface oceans. These moons have more liquid water than all of Earth's oceans combined, kept warm by tidal heating. Despite these promising signs, we face the Fermi paradox. If life is so likely, why haven't we heard from anyone? The SETI Institute has been scanning the skies for radio signals for decades without a definitive hello. Interestingly, the WOW signal received in 1977 remains one of the most intriguing anomalies. It was a strong, narrow-band radio signal that matched the profile of what we expect from an artificial extraterrestrial source. One explanation for the silence is the Great Filter theory. This suggests that there is a hurdle in the evolution of life that is extremely difficult to overcome, preventing civilizations from reaching interstellar travel. Moving forward, the question becomes, have we already passed the filter, or is it still ahead of us? If the filter is in our future, it could mean that technological civilizations naturally destroy themselves before they can spread. However, new technology like the James Webb Space Telescope, JWST, is giving us fresh hope. JWST can analyze the chemical composition of exoplanet atmospheres, looking for biosignatures like oxygen and methane. By detecting these gases in the right proportions, we could find indirect evidence of life without ever leaving our solar system. This would be the greatest discovery in human history. Beyond the science, public perception is shifting. Global surveys show that a growing majority of the population now believes that extraterrestrial life exists somewhere in the universe. This shift is fueled by the declassification of unidentified aerial phenomena, UAPs, by governments. While not proof of aliens, these reports confirm that there are objects in our skies that defy current explanation. In conclusion, while we have no smoking gun evidence yet, the data suggests we are on the verge of an answer. The universe is too big, and the ingredients for life are too common for us to be a unique accident. As Arthur C. Clarke once said, two possibilities exist. Either we are alone in the universe, or we are not. Both are equally terrifying. Perhaps one day soon we will finally know which it is.